Good morning. Our project is AI based early warning system for power grid failures. Power grid failures can happen because of overloads, voltage changes, or equipment fails, which may lead to the power cuts. Our project helps predict these problems before they happen by monitoring important electric parameters and using AI to detect unusual patterns. The system gives early alerts. This helps in prevents the failures and improve the reliability of the power grid. Coming to the system architecture, first we collect the input parameters such as voltage, current, power factor, temperature, voltage fluctuations from ESP32 and DHD sensors. Then this data goes to pre-processing where it gets cleaned and normalized. Then this data is fed into our LSTM model. Our LSTM model also considers the past 8 readings and also uses a sigmoid function, and instead of using the 0.50 as threshold always uses the dynamic threshold in order to detect the risk of overload or transformer fault. If the risk is detected, the LE system generates alerts, and finally all results are displayed on the dashboard for real-time monitoring and analysis.
The purpose of this hardware setup is to create a real-time transmission system environment and continuously collect live electrical data for our AI model. This is the sending end panel, which represents the generation side or sending substation. From this panel, power is supplied into the transmission line model. Here we measure sending end voltage, sending end current, and sending end power. The voltage meters and current meters continuously display these values. This acts like a real generating substation feeding power into the transmission lines. These are the protection relays. These relays provide protection. They include under voltage relay, over voltage relay, over current relay, earth fault relay. If abnormal conditions occur, these relays can trip just like real substations. This middle section is the transmission line model. It represents actual transmission line parameters such as resistance, inductance, and capacitance. These sections simulate short, medium, and long transmission lines, and it also behaves like a real power transmission network. For fault or stress creation, we can manually create abnormal conditions by increasing load, disconnecting the sections, and creating overload and simulating the faults using this load bank. This helps us generate real-time stressed conditions. This is the receiving end panel of our system. It represents the consumer or load side of the system. Here we measure receiving end voltage, receiving end current, and receiving end power. By comparing sending and receiving values, we can identify the voltage drops and losses. For example, if the sending voltage is 58 volts and the receiving voltage is 50 volt, this voltage drop indicates stress in the transmission line. For the data acquisition, instead of using expensive data acquisition systems, we use ESP32. Voltage and current sensors are connected to sending end and the receiving end. ESP32 continuously reads the sending end voltage, sending end current, and receiving end voltage and receiving end current. So the real-time data flow is as follows: transmission setup to sensors to ESP32 and to the left. So this hardware setup allows us to validate our AI model using real electrical signals instead of just relying on simulation.
Readings from the hardware setup, which is collected from the ESP32 and DHD sensors, is given as the input to the model to predict the output. So the model predicts the output based on the readings currently entered by the user, and it also sees a window of last 8 readings to predict the output. Suppose say the voltage is 224 volts and the current flowing is 20 amps. The power factor is 0.95 and the voltage fluctuation between the receiver ends and the sender ends is 1.5. and the temperature is 38 degrees Celsius, and the humidity is 35 degrees, and the model predicts with a minimum latency of 1 to 2 seconds, and the condition of the grid here is stable. Suppose if we take the readings uh, as voltage 226 volts, current 18, the power factor being 0.84, the voltage fluctuation being 2.84, the temperature is 40 degrees, and the humidity is 35. uh, and now this leads to a condition of over risk, as the value of the predicted risk is more than the threshold overload. It predicted that it may leads to the overload condition and grid may fail due to that. And users can also see the past arrest history with the timestamp and the date, and also the reason for the power grid failure. Thank you.